All right, so at this point you guys should all be into the My Notre Dame. First thing we're going to do is to set up our Delta Math. So new classes, new people in the classes, we're going to just set up a new Delta Math. So go ahead and hit the Delta Math link registration here. That should open you right up to Delta Math, and it'll put you on the login, or I'm sorry. Hi, Cheyenne. Anywhere you like. So if you click on it, it'll bring you all the way in with the class code already in it. All you have to do is hit register with Google and pick your Google account or whatever, and it'll take care of itself. Use your school Google. Not that that was probably... but it's super easy. It just takes a second. As soon as you're done with that login, you can close out of Delta Math. We're not doing anything else with that today. Oh. Yep. Once you're done with getting your Delta Math all set up, you can close that out and then just open up Microsoft Teams. The next thing we'll do is be setting up our shared OneNote. So I'm just yeah, for whatever, I guess I mislabeled these as third and fourth hours, huh? Boy, that's pretty dumb, Mr. Gulick. Oh my goodness. There we go. Okay. Good. So that looks like it's going fine. All right. Go ahead and open up your Microsoft Teams. This is the one day of the semester we use Microsoft Teams, and it's just to load in our shared OneNote notebooks. So if you go into your Microsoft Teams, you should see a tile called 4th Hour Pre-Calc. Go ahead and click that. You should get a screen that looks like this. From the navigation panel here on your left, you're just going to pick Class Notebook. Take a minute for the OneNote to load in. Once it does, where it says Open in Browser, you're going to pick from the drop-down Open in Desktop App. And that'll open up your OneNote and it'll load in your new OneNote for the semester. Everybody's cool? I'm going to talk for a minute while you guys are just kind of completing that. I am going to probably on Monday delete out the last semester's OneNotes to free up some hard drive space on my computer. So if you have stuff in the first semester OneNote that you'd like to keep for yourself, you need to move that to a non-shared notebook inside of your own OneNote. So you just need to move your stuff so that you still have access to it after I delete all the backups from my location. Everybody's cool? Anybody have issues getting the OneNote to load in? Corey, you're good? Okay. All right. All right. So take a look at the syllabus, and we're just going to do this briefly because it's almost exactly the same syllabus from first semester. So I'm not going to belabor a lot of this. Corey, I think you're the only new person in here today. At some point, you should probably take a quick read through. It's pretty standard stuff. If you have questions, though, feel free to ask. But all the same setups as first semester. The only thing that changed is the stuff that we're going to be working on. So that's the only stuff that's going to change from first semester to second semester. And notice that after chapter 7, the trig stuff is no longer coming up. So all of these are going to be review of things that you would have typically done in your Algebra 2 class. I know that wasn't the case for most of us. So we're going to go and fill in some of those Algebra 2 gaps here during this semester and talk about some of these ideas that you didn't spend a lot of time with or any time last year. Okay? All right. So this syllabus is here in the content library of your OneNote. You could also find this on the My Notre Dame page. If you did the syllabus sign-up sheet in first semester, I don't need you to do it again, Corey. I think that means you're the only one that needs to do it. You can print it and do it in paper, or like on paper. You can do it digitally and just drop it into your OneNote. Either is fine with me. If you need help doing that, I can show you how to do that in a minute or whatever, or at a future date. Not a big deal. Sometime next week, though, would be good. Okay. Cool. So there's all that stuff. So today, we're going to go ahead and start with chapter 3. Here's the nice thing about chapter 7. Why did I say chapter 3? I hope we're not going back to chapter 3. We're really far behind if that's the case. Good part about chapter 7 is it's pretty easy, which is a nice place to start. All right. So in chapter 7, we're going to look at some of these geometry ideas inside of non-right triangles. So we should remember from first semester, if we wanted to solve a right triangle, we could just really use our SOHCAHTOA definitions for sine, cosine, and tangent to do this, right? But what happens if we don't have a right triangle? Because that's a pretty specific, special situation. That's what we're going to deal with here in chapter 7. It's like, what happens if I don't have a right triangle? How can I do stuff? Whether solving the triangle or finding an area for the triangle. How do I do that? So let's just kind of look at that situation. So here is just some generic non-right triangle. So remember the way we typically label a triangle. We use capital letters for the vertices. And then we name the sides with the lowercase letter opposite the vertices. So like side A is opposite angle A. Everybody kind of remember that? The same naming convention we used in first semester. So here's the deal. We have this non-right triangle. What am I going to do? Well, I'm going to pick one of the vertices and drop an altitude. So remember, an altitude is a segment inside of a triangle that starts at one vertex and is perpendicular to the opposite side. In doing that, I've created two right triangles. This one here in yellow, and this one here in green. I'm going to label that altitude's length as h. And now I can say the following. Inside the yellow triangle, since that's a right triangle, I can use SOHCAHTOA to say that sine A is equal to opposite over hypotenuse. And then using the green triangle, since that's a right triangle, again, I can use SOHCAHTOA to say that sine of angle B is equal to opposite over hypotenuse. Everybody's okay with what I've written so far? My observation here is that, great, look at this. Both of these two equations involve this altitude length h. So I'm going to get the h by itself so I can set these two equations equal to one another. So in my first equation, I'll just multiply both sides by b. And in the second equation, I'll multiply both sides by a. And then since they're both equal to h, they must both be equal to each other. Feeling good so far? And then my final step, what I'm going to do is I'm going to divide both sides by AB. So when I do that, the B's cancel on the left and the A's cancel on the right. And what we're left with is sine A over A equals sine B over B. Notice that this relationship holds for non-right triangles and is only reliant on angle measures of the triangle and side lengths of the triangle. I don't actually need that value for that altitude h that I drew in there. It doesn't end up in my final formula, which is fantastic. This is only part of the law of sines. To finish it, what I would go back and do is I would go back to my picture, draw on a new altitude either from A or B, and repeat the same process. In doing so, I would end up that this is also equal to sine C over C. And it's this relationship that we call the law of sines. I abbreviate that as LOS. Law of sines. So let's do some examples now of kind of incorporating that, using that to do some stuff. Uh-oh. There you go. So let's see how we use this law of sines now. So it says in a triangle where angle A is 32 degrees, angle B is 73 degrees, and side C is 13 inches, asks us to solve the triangle. When I say solve the triangle, that means we need to find the values for the other unknown parts. So in this case, we're looking for angle C, side A, and side B. Those are the three things that were not given in the problem. So far, so good. I'm going to start by just kind of drawing a picture of my situation. And I'm going to add in the values that I'm given. Now, if I look at my law of sines, in order to use this, I need to have both angle A and side A. I don't have that. Or I need to have, oh Boise, angle B and side B. I don't have those. Or I would need angle C and side C. Well, I don't have both of those. However, I can find one of angle C, side A, or side B right away, really simply, without having to do any trigonometry at all. Which one do you guys see that I can do right away? Angle C. You are correct, sir. What could I do to find angle C? Great. So I know there's 180 degrees in the triangle. So if I take the other two angle measures and subtract them from 180, that's got to give me the value for C. So that's going to be 180 minus 105, which is 75 degrees. Is everybody happy with what I did there as our first step? Now that was key because that means now I know an angle and its opposite side. So I'm going to use that in my law of sines to solve for either side A or side B next. It does not matter which one I do first. So for the sake of alphabetical order, I'm going to find side A next. So I'm going to write my law of sines. I'm going to say sine C over side C equals sine A over side A. So using the law of sines, notice that there's three things that are equal to each other. When we actually go to use it to solve something, I'm just going to take any of the two and set them equal to each other. They don't have to necessarily be next to each other. Notice sine C over C is not next to sine A over A. That doesn't matter. I can still set them equal to each other because everything is equal. Okay. So this type of equation where I have one fraction equal to another fraction is called a proportion. Do you guys remember from geometry how to solve a proportion? So the technique to solve a proportion we use is cross multiply and divide. Remember, cross multiplying isn't how we multiply fractions, it's how we solve a proportion. So when we say cross multiply, we'll do a times sine 75 equals 13 times sine 32. So that gets rid of the fraction parts of my proportion. Again, we're trying to solve for a. So the next step I would do is divide by sine 75. Everybody's good with that? So the typical instructions when we solve a proportion, we say cross multiply and divide. And now it's calculator time. So I'm going to go and type this into my calculator. To do this, I'm going to be using sines and cosines, right? What's the first thing I need to check before I start diving into this, especially if I haven't picked up my calculator in, 3 weeks or so? Check my mode. What mode should my calculator be in? Degree. How do I know that? The angles in the problem were in degrees. Yeah, very good. So mine was in degree mode. So I'm going to say alpha y equals and pick the first fraction option. That'll give me the fraction bar on my calculator. So now I can type this in exactly the way it looks on my screen or on my sheet of paper, which is lovely. You don't need to use that, but boy, it certainly helps clean up any parenthesis problems that you might have by using that, taking advantage of that command. So I do that, I get 713. And what did we say? I think these were in inches. All right. So now to solve side B, I know 2 of the 3 sides, so I can just use the Pythagorean theorem, right? Wrong! Why can't I use the Pythagorean theorem? No. What kind of triangle do I have? Not a right triangle. Can't use the Pythagorean theorem unless we have a right triangle. Everybody's cool? Caught you. Ha ha! All right. So what do we do instead? Do the law of sines again. Okay? Now we have a choice, though. We can do sine C over C, or we can use sine A over A. Which one would I prefer? Does it matter? Depends on how precise you're trying to be. Which one is going to be the more accurate way to go? Using C. Why? Nothing has been rounded. Exactly right. Yeah. So in general, if we're just rounding to 2 decimal places, it probably doesn't make a lick of difference. But if you're like working for NASA and trying to land a ship on the moon, 2 decimal places is probably not good enough. So when given the option, I will always pick the one that I didn't have to round. If for no other reason, then what happens if I made an arithmetic mistake in calculating the length of A? If I just made some stupid mistake on finding A, and then I use that to do the next problem, or the next part, and get it wrong because my previous answer is wrong. If I use the one that the book gave me, I know those answers are fine. Another good reason to just go with that one. Notice this is going to be the exact same process now of what I just did, right? The starting equations are the exact same setups. We're going to be the exact same steps. It's going to be a lot of the exact same thing over and over and over again in this chapter, which is lovely. I like it when it all feels the same, right? Isn't that nice? All right. Cross multiply and divide. And then, so there's my cross multiplying. Got to get that b by itself, so divide by sine 75 next. Go to my calculator and just type that in. Again, I like to do alpha y equals and then pick that first fraction option to give me the fraction bar, which really helps eliminate any like major order of operations problems or like parenthesis issues when I'm typing stuff into my calculator. And I get 1287. Oh, and I should probably say inches there, huh? There's a unit on that. I think the problem was in inches. We feel okay so far? No big deal, right, Ava?
How did you get it, like, example number 3?
Uh-huh.
How did you get it from, like, that form to the next one, where it was b sine 75 over sine 75?
So I cross multiplied. So I have b times sine 75 equals 13 times sine 73. And then I chose to divide by sine 75 to both sides to get the b by itself. No problem. So let's check, right? Now I'm not going to check exactly. I'm just going to do a little eyeball check. And usually this check is good enough. I remember from geometry that the biggest side should be opposite the biggest angle. That's true. I know that the middle side should be opposite the middle angle. That's true. And I know the smallest side should be opposite the smallest angle. That's true. I feel pretty good that it is correctly. Now, is that going to catch it all of them, your mistakes? No, not necessarily. If you get to like the last step and you just transpose a decimal point or something, copying it down, you won't catch that. But if you've made some big setup error, it'll definitely point that out to you. Everybody's cool with that? So all I'm doing is just checking that the biggest thing is across from the other biggest thing, medium across from medium, smallest across from smallest. And usually that'll catch, the vast majority of our mistakes. Let's do another example. First time many of us are probably doing this. Do you guys remember doing this in geometry? I think the honors kids do this in geometry. I'm not sure if the traditional class does this then or not. Do you guys remember doing this?
It wasn't ours, but it was a long time ago. So.
Yeah, fair. Definitely fair. Last year it was like we did this during the pandemic. I can't remember. Like the virtual learning time was caught. I had a lot of that, so we had to go back and really reteach a lot of stuff specifically from geometry because it just wasn't there. You guys don't have that excuse, I think. Yeah, but it was like a week or something, right? Or 2 weeks.
Yeah, it was like the first 2 weeks before we were breaking.
Yeah, it wasn't like the whole second semester.
Yeah.
Well, you're really only getting like 2.5 weeks in December. And you really have the whole last week of November is like a break. But yeah, you missed a little, but it might have been 1 unit. All right. Let's do another. So what do I want to do? I want to start by drawing my picture. So the third letter I'm going to use is going to be R because the alphabet. Let's see, P is 43 degrees, Q is 80 degrees, and then side Q is 73 or 7.3. So what do I have left to find? I have to find angle R, to find side R, and I have to find side P. Everybody cool with that? Okay, so first off, actually I have 2 choices as what to do first, right? Notice unlike the previous problem, here I have an angle and its opposite side. So I could solve for angle P first, or I could solve for, side P first. I know angle P. Or I could solve for angle R first. Doesn't really matter. What would I do? I'd solve for angle R first because, like, that's really easy. So just like before, (180 minus 43 minus 80 is just 57. And I like to write my answers in as I go. Again, you don't have to do that or whatever, but and now for my next step, I know I'm going to be doing sine Q over Q, but it doesn't matter now whether I do sine P over P or sine R over R, right? I have enough information to do either one. Doesn't matter which to do. I'm going to choose to do alphabetical. I'll do sine P over P next. So again, we'll cross multiply. And then we'll divide to get the P by itself. So divide both sides by sine 80. And then it's calculator time. And I get about 506. What did I think? I think these were in centimeters, I think is what the directions said. Yep. And then the last part, again, I'm going to use sine Q over Q because no rounding involved. Everybody still good? If I get going too fast, holler at me or whatever. We'll cross multiply. And then we'll divide by sine 80. So I should write it. And I get 622-ish. If I go and I write that one in, and then I do my check, biggest across from biggest, middle across from middle, small across from small. That all looks pretty good to me. So I'm pretty convinced I'm on the right side of things here. So far, so good. Okay. So let's go back to geometry here for a minute. And what I want you to remember is proving that triangles are congruent. So they had like 5 theorems, I think, on how to do this. Most of them were like a 3-letter acronym. Anybody remember any of those? Nathan?
Side, equal side.
Yep, that was one of them.
Nathan, side, side.
Great.
Angle, side, angle.
Angle, side, angle. Uh-huh. Angle, angle, side. That is not one of them. That's a similarity. That's a similarity theorem, not a congruence theorem.
Angle, side, side.
The last one is called hypotenuse leg, which is a special case of side-side angle. We usually write it that way so you're not writing swear words, but you had the right idea, Sophia. And what's special about this is that the angle has to be 90 degrees for hypotenuse leg to work. So what is this? What's this saying to us? This is actually describing the cases in which we'd use the law of sines versus the law of cosines. Now, we haven't talked about the law of cosines yet, but we'll see that in another section or two. What do we use for this hypotenuse leg situation? This is still a law of sine situation, but we have to be very careful because in the SSA situation, we can end up with no answers, one set of answers, or two sets of answers, which is kind of a bummer. So we have to be really careful in this situation. And in fact, the situation where we can get 0, 1, or 2 is called the ambiguous case. And that's going to be the title of our next section. Yes, Sophia. Of course. Sure thing, dude. All right. So notice that in triangle ACD, this is an SSA, and triangle BCD has the same SSA congruence, right? Are those two triangles the exact same? Well, clearly they're not, right? We can see with our eyes immediately that those two triangles are definitely not congruent. So this is what we're saying. With this SSA situation, it's not enough to just have SSA to guarantee congruence. That's why you can get like two different sets of answers because, well, the SSA information you're given could be this triangle 1 or it could be triangle 2. You could kind of have two different sets of answers here. So what we need to do here is we just need to talk about how we determine the number of possible triangles. So let's say we have some triangle ABC, and we're given angle A, we're given side AB, and then we're given side BC. There's two different big cases that are described by the size of angle A. Now, so if angle A is acute, or when angle A is not acute. All right, so if angle A is greater than or equal to 90 degrees, what kind of triangle do we have? It's either a Well, if it's greater than or equal to 90 degrees, it's either right or obtuse. Everybody agree with that? How many right angles can a triangle have? Just one. And it has to be then the biggest angle. Everybody agree? How many obtuse angles can a triangle have? Just one. And it has to be the biggest angle. So what that's saying then is that if angle A is greater than or equal to 90, then side CB has to be greater than or equal to, or greater than AB. Right? Because CB has to be the hypotenuse. It has to be the longest side if it's opposite the biggest angle. So you'll get exactly one triangle in that situation. If that's not the case, then it's impossible, right? If you have not the biggest side opposite the biggest angle, well, that's nonsense. We know that that can't happen. No triangle is possible. You're done. That's not so bad, Mr. Kulik. No, it's not. Now, if angle A is acute and the side opposite angle A is the bigger of the two given sides, bigger or equal, that's fine, just one triangle. Our nightmare scenario is where the side that's given, that's opposite our acute angle, is the smaller side. That is the yucky situation where we can get 0, 1, or 2 triangles. And the question left here is, how do I tell, right? If it's going to be 0, 1, or 2. Have to have a way to be able to decide. Let's look at an example and we'll work out how to do that. All right, so we have some triangle where angle P is 56 degrees, side P is 16, and side Q is 19. Asks how many triangles are possible. I'm going to just start by drawing my picture. Everybody's cool? The picture I've drawn. Is this the SSA situation? Yes, because the angle I have is not in between the two sides. Everybody see that? The angle that we're given is not in between the two sides. If the angle you're given, if 56 is where it was angle R, where it's in between, that's angle side angle. Everybody's cool with that? Okay. So this is SSA. And I noticed that angle P is acute. And I notice that the side opposite angle P is shorter than the other side. This is my ambiguous case. That's what we call this, specifically this situation. Ava. So if I look at the sides that I'm given, they're not the arms of my angle. So the given angle, one of them is an arm of the angle, that's fine, but not both of them. Then it's SSA. Well, they're not both where the blue is, right? Like if I draw angle P, I draw the blue, right? If my givens are the blues, that's angle side angle. If the givens aren't the blue, then it's side angle. Is that okay? That's probably the easiest way to kind of see it in your head. Does that work for you? Okay. All right. So we know we're in the ambiguous case situation. We know we have an SSA. We know that the angle is acute, and the side that's opposite the acute angle is the shorter of the two givens. Okay, that's what we need to check, those three things. We've landed into the ambiguous case. So we know we can have 0, 1, or 2 triangles. We have to figure out now which one of those three is going on. All the other situations I can tell just from the given information. Here I need to do some additional calculation. So what I do is I'm just going to use the law of sines on what's available. So I'll do sine 56 over 16 equals sine q over 19. And that's the only law of sines equation that I can write. Everybody agree? Since I'm missing 2 angles, I can't get away with doing anything else. So what I'm going to do now is I'm going to solve for sine of angle Q. I'm going to solve for sine of angle Q. So I'll cross multiply, just like I've done before. And then I'll divide by 16. And I want to look at what that number is. So I'm going to go to my calculator and type in 19 times sine 56 over 16. So I get 0.984. And it's this number here that's going to tell me what's going on. Okay? So think back to last semester. If I take sine of an angle, what's the biggest possible value I can get for sine of an angle? Think back to your unit circle. Sine is the y-coordinate. What's the biggest y-coordinate on the unit circle? It was 1, right? So if this number is bigger than 1, that's impossible. That's going to be 0 triangles. right? Because I know that sine of an angle can never be something bigger than 1. Everybody's cool with that? Does anybody remember what angle gives you exactly sine of 1? It was a 90-degree angle. That's going to be the one triangle situation. That's actually our hypotenuse leg situation that you remember from geometry, is where you have the SSA and the angle is a right angle. Then you get triangle congruence out of there because there's just one thing can happen. And if that number is less than 1, 2 triangles are possible, which is what we have going on here. Yes, Matt? Certainly. Everybody feel okay on that? So again, there's a bunch of criteria you have to sort through, but it basically comes down to if the given angle is 90 degrees or bigger, just have to make sure the triangle is possible by making sure the longest side is across from the biggest angle. And if it is, 1 triangle. If it's not, 0 triangles. That's it. If it's acute, if the given angle is acute, you have to check to see if the side opposite the acute angle is the shorter side. If it is the shorter side, then you have to do this calculation here. If it's not, it's just 1 triangle. Does everybody feel okay with this? Let's solve this the rest of the way to kind of see how am I going to get 2 triangles out of this now? Everybody's okay with that? In my experience, this is the most difficult thing we do in this chapter. And really, the thing that makes this the most difficult is just like students keeping track of what information goes where. So we know we're going to be getting 2 triangles out of this. We know we're going to be solving for angle Q, angle R, and side R. So I'm going to get a set of answers in triangle 1, a set of answers in triangle 2. To help me make sure I remember what number goes where, I'm going to put a subscript for the angle QR and side R for triangle 1, and a different subscript for the angle Q, angle R, and side R in triangle 2. Everybody's okay with what I did there? Okay. So let's do triangle 1 first. I'm going to start with this equation. Everybody's okay? Where that came from? That was just what I used to determine what was going on, whether it was 0, 1, or 2 triangles. Okay, I need to solve this equation for Q. How do I do that? So first semester trigonometry question. Let me ask it a different way then. What is going to cancel out the sine in front of angle Q? What? Not division, right? Because sine isn't being multiplied to Q. It's like an operation on Q. Do you remember what cancels out sine? It's not cosecant. That's the reciprocal of sine. That'd be just like dividing by sine. Not what we're looking for here. What we're looking for is sine inverse. Remember, the inverse, these inverses are what give us angles back. Come on. So I'm just going to go to my calculator. And we'll do second and the sine button to get the sine inverse. And then I'm just going to use that previous answer, the 0.984. So I get about 79.9 degrees. So that's my value for angle Q1. Everybody's cool there? Okay. Angle R then is going to be real easy, right? So 52.1. Oh, I should have written that as 78, 79, 89. Oops, a daisy. And what was that at 52.11, right? Yeah. Is everybody still doing okay? Okay. Now I just have to find side R, which I can do now. So I'll do sine P over P. Shoot, was that 10? What was that again? Oh boy. Oh boy. Look at that. It was 56, not 48. What did I remember? Hold on a second. Come on, you dumb thing. $44.11. Everybody okay with what I did there? So I'm just going to now cross multiply and divide. So there's my cross multiplying, and now I'm dividing. So 1343. So that's my set of answers for the first triangle. Here's the good news. Second triangle, a little bit easier to get the answers for than the first triangle. Here's the trick. So this first angle that we found, in this case it was Q1. Q2 is its supplement. Always, but only for the first angle. So that's 100.11. And boy, that was a lot easier than having to do the law of sines again, right? Now I can calculate angle R2, because I know that's 180 minus 56 minus our Q2. Everybody's okay with that? Just using that triangle sum theorem from geometry. So 2389 for that one. And then to find side R2, here we're stuck still doing the law of sines. So cross multiply and divide. That gives me 782. What do you guys think? That right there is the hardest thing we do, I think, in this chapter. Which, again, none of the individual steps are that difficult. There's just a lot of steps to it, right? It's just a long process because there's a lot of stuff to find. At this point, you guys should be able to do up through 14. And nothing is due for you guys. The first problem set is going to be on the 15th. So you don't have to worry about anything until not this Sunday, but next Sunday being due. Although, what is my recommendation? Do it now. Don't wait and do it all at once. Do a little bit every day. The learning goes much, much better if we do a little bit every day, right? Okay. I'm going to stop here.